Welcome back, college and schools, personal finance students. This is Mr. Clem, and we are going to move on to Chapter 6, and we're going to cover some time value of money concepts. You've maybe heard the statement that a dollar today is worth more than a dollar tomorrow, or a dollar a year from now, or 10 years from now. The time frame doesn't necessarily matter, but it's worth more today than it is down the road. What do they mean when they say that? Okay, how is that statement accurate? What they're trying to get at is a dollar received today is worth more than a dollar received sometime in the future. Why? Well, because you can either take that dollar today and deposit it in a savings account, which nowadays savings accounts are 3, 4, 5% interest, and you then wait a year, that dollar would be worth more than a dollar, right? Or you could look at it and say a dollar today is better than a dollar a year from now due to inflation, because inflation, the general rise in prices, a dollar today could buy more than a dollar a year from now. We're in the fall of 2022 or 2023, sorry, and gas prices just went up. They were in the $3.50 per gallon, and now they're up to like 405, 410, 415. Right? It seems like that's the way it's going for the fall. Now, a dollar is a tough number to deal with. How about we say $100? How much gas could Mr. Clem buy at $3.65 a gallon versus how much could I buy at $4.15 a gallon? Well, if you had $100 and we were at $3.65 a gallon, you could buy a lot more than whatever gas prices are going to be a year from now. And gas isn't always the greatest example because it does go up and does go down. But the idea that you can invest money now, it'll grow to more than that $1 of value in a year, or inflation will make things more expensive, so in turn you'll be able to buy less in the future. So as we start looking at it, we're going to start, and these are some ideas you maybe have heard, you maybe know pretty well. We're going to talk about the idea of calculating interest. And the first one here is simple interest. We need 3 bits of information to make simple interest calculations work. We need the principal, which is the amount of money you've got going in there. You need the rate, and normally it started out with an annualized rate of time, meaning if you waited for a year, this is what it would be. Not every calculation is going to be based on a year, so you may have to chop that rate to something less than 1 year's worth of time. And then the last part is time. Right? So our story here is you wrecked your car and you don't want to ask your parents to help pay for the damage. So you go to Mr. Clem, and Mr. Clem's a businessman. He says, sure, I'll give you a short-term loan, but I'm going to expect you to pay me back the amount of money you borrow, and I'm going to expect 3% simple interest. And maybe that's a better rate than the bank is giving you. Maybe it's better than mom and dad yelling at you, whichever way it happens to be. So as we look at doing math, it's going to be a $5,000 fix to make your car work again. So the $5,000 is going to be the principal. I'm charging you 3% simple interest, and we think you're going to be able to pay me back within a year. So my simple math formula is principal times rate times time, or the 5,000 times 3%, or 0.03 times 1. You're going to have to pay me back the original $5,000 in interest and another $150. So I'm going to get $5,150 back in a year's time. Well, what if you work hard and you're able to pay that bill off in 6 months? Should I still expect to get $150? Should I still charge you $150 in interest if you're only borrowing my money for 6 months and not a year? Well, I hope you'd be able to argue and say, I only borrowed it for 6 months. I'll pay you back $75. Still the same 5,000 bucks in principal. Still the same 3% interest. However, now my time frame is getting split, right? 6 months out of a 12-month year, or 0.5, or half, right? You're borrowing my money for half a year, so you're borrowing it for half as much. So in turn, you should pay half as much in interest. Similar deal, but as opposed to Mr. Clem saying he wants simple interest, what if he asks and expects you to pay compound interest? And I want that interest to be calculated or compounded every 3 months, similar to the way the bank does it. You'll pay me back that same amount of money in 1 year. So what's the difference? The principal is the same. The $5,000 doesn't change. The interest rate, the annual interest rate, doesn't change. That's still 3%. The difference now is my time is broken into two pieces. It's broken into how often is the interest going to be calculated, every 3 months, and for how long are you going to do this calculation, or how long is it until you're going to give me my money back? Well, in this case, it's going to be 1 year. So if we're doing this every 3 months for a year, we're doing our math 4 times. So we start out, same 5,000 bucks, same 3% interest, but we're going to calculate it on a quarterly basis, or every 3 months out of a 12-month year. 3 months comes and goes. We're going to rack up $37.50 in interest. I'm going to take that $37.50 and I'm going to add it back to my original principal. So now, starting month 4 to 6, I'm starting with a balance of $5,037.50. Interest rate stays the same. How often it's getting compounded stays the same. But when I do my math, what's going to happen? Is it going to be the same number there? Is it going to be more or less? Well, I hope your answer is more. Why? Because the original principal grew. And it grew due to the interest being compounded and then added back to the original principal. So second time around, that number is going to jump up to $37.78, right? It grew by about 28 cents. Now, we could use some ballpark math and say, all right, if it went from $37.50 to $37.28, we could probably say it's going to grow another 38 or 40 cents. And my third go round would be $38.678, right? Or when you're doing your math, you could look at that and go, if it grew from 1 to 2 by 28 cents, it's not going to grow from 2 to 3 by like $50, right? It should grow by 30, 35 cents, and then so on and so forth. Now, each time it's going to grow and it's going to get larger, and it'll get larger quicker, but the jumps are going to be roughly the same. So if we break it out kind of old school Excel, if you will, right? Here's our original 5,000 bucks. Here's our 3% interest as a decimal. We're compounding it every 3 months, 3 months out of a 12-month year. First round of math got us $37.50. Added it back to the principal. Time is the same. How often is the same? It grew by 28 cents. Add this number back to the original principal. Let it ride again. It grew by roughly another 28 cents. Let it ride again. And again, it's growing by 28, 29, 30 cents per, right? So it's getting bigger. That's the idea on compound interest. So we go compare these two options. What's the difference? My simple interest after a year was 150 bucks. My compound interest was $151.70. $1.70. Now, again, we're not getting rich on the difference because the difference is only $1.70. We only had $5,000. We were compounding it quarterly, and we were only doing it for a year. Take that concept and look at what if I was doing this on a $250,000 mortgage and my interest was calculated on a monthly basis, right? Or what if it was a $20,000 credit card and that's calculated on an average daily balance? Those numbers would grow much, much quicker. But from a concept standpoint, this was a nice, simple example of how do you do simple interest? How do you do compound interest? We got a couple ways that we could do this math. We could do it the long way, the old school spreadsheet way. If we take a look at the old school spreadsheet way, right, we start out with, let's zoom this up so we can see it. We got principal, we got rate, and we've got time. Calculation is going to figure out our interest. So we start with that $5,000 in principal. We've got 3%, and time was 1 year. Principal times rate, time, principal times rate, times time. Here's how we cranked out the 150. For those not super savvy on the spreadsheet, because I changed this cell to have dollar representation, that's why this formula had dollar representation, because this formula was based on something inside of that. We can look at the compound one, principal, rate, time, interest. And again, I like to do this how many, and I kind of plan it out almost backwards, right? I start with my $5,000 of principal. I've got 0.03 or 3%. Either way, these mean the same thing. I can type in 0.25, or I can say equals 3 divided by 12. Either way, that's 0.25. Now, if I'm doing this every 3 months for a year, I'm doing my math 4 times. Here's my key. This is my answer over here. This is not my final answer, right? This cell right here is principal times rate times time. $5,000 times 0.03 times 0.25. Go ahead and add back my original principal to my interest rate. My rate and my time are the same for all of my calculations. And I can use my fill handle to go ahead and drag things down. Too many times people say, oh yeah, I did my 4th calculation, I'm done. No, you're not, right? This 51, 13, 35 still gets that amount of interest added to it, so I got to drag this bugger down one more time to get my final answer there. 51, 51, and 70 cents, as opposed to this answer here of 51.50. Right? There's my math. If it's me, I'm kind of a dork. I like to label these things. That's simple interest. Over here is compound interest. That's the long way. And I'm going to ask you to do the long way a couple times just to get the idea down and feel good about it. There's another way. There's an algebraic way to do it where you can calculate the future value of something by using this formula here. What's the present value times parenthesis 1 plus the interest rate? I'm not great at that. I'm just going to be upfront and honest. I'm not great at that. I don't like that one. I would much rather do it either the long Excel way, or I would rather do it here the future value calculation way. And this will be the last bit of this video as we look at simple and compound interest. We're going to look at how we use it in calculating future value calculation, or the Excel formula future value. When we look at a future value calculation in Excel, we start out with an equal sign. Every time we're going to write a formula in Excel, and yes, I mean Google Sheets as well. I'm old and I'm just going to call it Excel, even though I know it's Google Sheets. My Excel formula is equals future value. And then I open my parenthesis, and at the end, there's a close of the parenthesis. Now, in between is all the bits of information I need to know. I separate those bits of information with a comma. Right? So this one is asking for what's the future value when I know the annual interest rate, when I know the N per, when I know the payment, when I know the present value, and when I know the type. Right? So all functions start with an equal sign. Since we're wanting to know the future value, right? We know what it's today. What is it going to grow to in a year? So our formula is going to be equals future value. Open up the parenthesis. The rate piece to our formula, that's our annual interest rate. Now, not every interest rate is going to be annual. So we maybe have to chop that up by either multiplying it by a percentage or dividing it by a number to say, turn your annual rate of interest into something that is not an annual rate. If we were doing it quarterly, right, like we were in that compound interest side, we would either divide it by 4 to take an annual number and turn it into a quarter of a number, or we take it and multiply it by 0.25. And either way, you'll get the same thing, right? 3% divided by 4 is the same thing as 3% times 0.25. So you can write formulas in here. Our N per, or number of periods, is a fancy way of saying how many times are we going to do our math. Now we can do this future value calculation for both simple and compound interest. If we're ever doing a simple interest calculation with future value, the N per has to be 1 because we're only doing our math one time. If we're doing a future value calculation and it's compound interest, this number is going to be how many times are you doing your math in total? Well, in the sample we were doing it every 3 months for a year, a total of 4 times. So the N per in our example is going to be 4. PMT piece to the equation is payment. And this is going to be a little bit more advanced. We'll deal with this later when we actually put numbers in there. Right now, most times it's going to be 0. If I'm dropping money into a bank account one time, I drop my $5,000, whether it's with Clem or with a plain old regular bank. If I drop my $5,000 in one time, one deposit of $5,000, and I'm going to let it grow at a specific interest rate over a specific period of time, the payment's going to be 0. That's not always the case. What if I'm going to add money to the account? You think of your 401k or your 403b, maybe a Roth IRA, where you're going to be depositing money on a serial basis or an every month kind of basis. That's called an annuity. We'll get to those in a little bit, or at least that's the way we write the function. On the flip side, you could be getting to the point where you're going to draw some money out, right? Maybe you are going to put a pile of cash in, and every month you're going to draw out a certain amount, or every year you're going to draw out a certain amount of that money, right? You'll see endowments that are similar to that, where you put in a very, very large sum of money, it earns a specific rate of interest over a period of time, but you're going to take out some of that interest earned. Maybe it's some of it, maybe it's all of it. Maybe it's all of the interest plus a little bit of principal. Again, those are a little bit more advanced ideas, but we will get to those. So the Clem way of saying it, are you going to let it ride? Right? They calculate the interest. Are you going to let it ride? Or are you going to take it out? For now, if we say 0, we're going to let it ride. Present value, PV, that's going to be the amount of money you're depositing. Right? So in this formula, the $5,000 is going to go here. The 3% interest rate is going to go here, and we may need to adjust that annualized interest rate if it's simple or compound. And how many times are we doing our math there? Payment function 0. Last up is our type. When is the money getting put in? Is it put in at the end of the period and we're going to put it in with a 0? Or is it put in at the beginning of the period and it's going to be put in with a 1? right? Are you going to wait till the end of the month to take the money and drop it in, or are you going to put it in the beginning of the month? 9 times out of 10, we're using zero, right? But obviously that matters whether you're earning interest that first 30 days or not. So let's go back to our simple math formula here, and let's write our future value formula. So we want the rate. That rate is going to be a 3% annual rate of interest. How many times are we doing the math? Well, we did the math one time there. How much was the deposit? Well, it was $5,000. Now, it doesn't like commas. If I do 5 comma, it thinks I'm depositing $5. That's not accurate. We don't need the dollar sign. We just need 5000. Oh, I'm sorry. That's supposed to be 0 because that's payment amount. We're not taking any out. Present value is supposed to be 5,000 and 0. I'm going to put an apostrophe here, and it's going to show you exactly what I wrote the formula, how exactly I wrote the formula. Equals future value, 3%, 1 math calculation, no money leaking out, 5,000 deposited, 0. Now, it shows up as a negative number, and that will probably work some people up and go, I don't like that that shows negative. I can go back in here and say, well, take it like it's the $5,000 that I am dropping into a savings account and turn that number to negative. My answer will spit back a positive number. Same idea here with our compound interest, right? Principal rate, time, interest, how many? Future value. My annual rate is 3%, but I'm not calculating my interest on an annual basis. I'm calculating it every 3 months. So either multiply it by 0.25 or divide it by 4. Either way, you're going to take that annual number and turn it into a quarterly number. How many times did I do my math? Well, I did my math 4 times. Payment, did I let any leak out? In this example, I didn't. I still dropped in 5,000 and at the end of the period. Now, this formula here wasn't super complicated, right? It's not super long. It's only 4 rounds of doing math. So whether you like the long way here or the future value way, this isn't hard. If we were doing an amortization schedule, or if we were doing, you're dropping in 10 grand and it's compounding monthly and you're 20 years old, and let's go see what it's like when you're 65. That's a lot, right? That's a lot of calculations to do. Future value is probably a more efficient way to get it done. Again, if we don't like that that number shows up negative, put the present value as a negative number as if you're taking the money out of your pocket and giving it to the bank. So as we review, we're talking the idea is that $1 today is not the same as $1 down the road, right, due to interest or inflation. We're looking at simple interest where we're doing math one time, both the old school long way here, Excel kind of formula way, principal times rate times time, or the future value calculation way. Now, there are financial calculators that'll do roughly the same thing. It's more like this future value calculation where you'll have to plug in the 5 bits information. What's the rate? What's the number of calculation? Is there payment? What's the present value and the type? We didn't purchase those. Those are something you can do on your own if you so choose. I'm going to go and ask you guys to do both the long and the future value way. And again, there's an algebraic way. I don't choose to use that. So if that works for you, awesome. But I'm going to ask these ways of you. And then how's a different compound interest? Principal rate time, how often is it getting compounded? How many times are you doing your math? All of these are dealing with one-time money getting dropped in and letting it grow into the future. So that's why it's called future value. We'll end with this one here, and we're going to move on to our second time value of money video, and we're going to deal with what happens if it's more than just a one-time deposit into an account.